This is a video about my final exam. My final this year is going to be structured a lot like foreign language final exam. If you take French right now or Spanish, then at the end of the year, it's while you're still in class, there's going to be two parts. The first part is going to be an oral part where you have to perform orally on some sort of examination, and that's going to be in class. And then the second part is given during finals week with everyone kind of sitting in rows and columns doing a paper pencil kind of a test. So it's in two parts. And if you were here at SCH last year, then you know what that looks like. My final exam is going to be structured very similarly. There's going to be two parts. There's going to be a quiz and a video. The quiz is going to be in class while you're still learning other things or still studying for final exams in some of your other classes. And then the second part will be a video project that you'll have to do while everyone is in rows and columns during final exam week and all in the same room. So let's talk about what's the same about this kind of the first part, quiz. It's going to be 10 multiple choice questions. I'm going to do my very best to make sure it's from 2 o'clock to 2:45 with an SAS bleed over. I'm pretty sure I can make that happen, but I'm not 100% because I haven't scheduled it out yet. It's going to be in my room. You'll be able to circle 2 for partial credit, and you have to show work. Very much like all the quizzes that's the same for all the quizzes we've taken recently. Here's what's different. When you take part 1, the quiz, in my room, it's not going to be on new material, but it's going to be on old material, old questions that I've already asked you. In fact, I'm going to give you a bank of 30 to 50 previously used questions. I'll give that bank of questions to you in advance, and you can practice it. We'll have time to practice it in class, and then you'll have to do some of your preparation outside of class as well. It's only going to be on semester 2 questions, but they of course rely on semester 1. You need to know semester 1 concepts in order to do semester 2 questions, but the questions are only from quizzes that have been in the second semester. And so there's a picture of what the question bank could look like. Part 2 of this is all going to be a video. You're going to have to produce, like you have done before, you have to produce a video where you extract data, pick a transform parent function, and make predictions and claims. Just like in this parabola project we had here. Once we produced the data, you had to put the photo onto Desmos and then turn the golf ball points into points that you could plot, make a parabola, and then make some claims about it. You used your laptop, you used websites, Desmos, notes, textbook, comic book. That's all going to be the same. Even though you're going to be in a different location, you're still going to be able to use these kinds of resources with you. What I'm trying to say is that you're going to be sitting in rows and columns together inside some sort of examination room. Last year it was in Cherokee campus, 2nd floor. I don't know if they're going to be the same place or not due to the construction, but we'll have to wait and see. Anyway, wherever it is that you are, you're going to be all sitting together, facing the front, rows and columns, with your laptops, with your headphones, producing videos, freely able to use your notes, your textbook, your websites. But what you can't use is you can't talk to each other. You can't use each other. You can't text other people. You can only use static resources. You can't actually talk to other human beings, whether they're inside the room or outside of the room. This is going to have to be an individual project. You won't have the option to find a partner. Everyone's going to have to produce their own. And instead of us producing the data, like we did in the parabola project, I'm going to give you the video data of some sort of event, like sand piling up next to a ruler, as you can see in the picture, and you might have to make a prediction about that. You're going to have to take the data from that event and turn it into points on a graph on Desmos, and then make some predictions about that. You're going to have to choose the parent function. For example, in the parabola project, we were talking about parabola, as I mentioned. Did I call it the parabola project? No. But it was well known that we were going to be trying to fit this to a parabola. I'm not going to tell you what parent function it is. You're going to have to do the science research, do the statistical research, and figure out what transformations you want to put on that parent function after you've chosen the parent function. In order to accommodate all this, I've got a modified rubric. It's going to be very similar, but there's going to have to be some differences. Like, you can't talk, for example. We can't have people talking in the exam room, so you can't talk into your computer and record your voice. So there's going to have to be no script either. You have to do everything visually and just add some music on if you want for some flavor. So there are the basic similarities and differences between part 1, the quiz, and part 2, the video. This is also, all of this information is also on Haiku, if you ever want to look at it on your own. So, and another thing that's also on Haiku is the new rubric. Here it is. Let's take it line one by one. So there's a central question, and the central question is going to be some sort of prediction. For example, if it were the strobe light parabola project, I might have a ruler next to the backboard and say, at what point does where does the ball hit the backboard? And you have to say, 5 centimeters up, or at 3 centimeters. The prediction is going to strictly be a value that you have to come out based on where the line on your graph, based on the graph that you produce from Desmos, and you can these percentages are not what I'm looking for. It should be 5%, 10%, 20% instead of more difficult of what you see here. The related questions in previous projects were open-ended, and I really like that because it helped you inspire curiosity, but we're going to have to narrow our focus a little bit here. The first related question, and there's 2 that I'm going to specifically state, is what are the different parts of the graph? So what are the intercepts? Are there any asymptotes? What's the domain? What's the range? In this case, you could name a vertex. What's the vertex? And what do all these things represent in the experiment? The domain represents something. The range represents something. In this parabola project, the range would talk about like what are the y values of all the points in the project. The intercepts would be maybe, depending on where you line up the picture, where the ball started. And you really do have to reinterpret those things in terms of the context of the experiment. You have to talk about what they mean in terms of what was actually happening back in the experiment. Like the vertex is the peak of the ball during its trajectory as it flew through the room. The next related question is, which parent function did you choose and why? So in the strobe light parabola project, we chose a parabola. We chose a parabola because it fit the points. You can see r-squared values that are very high when you choose parabola and incredibly low when you choose a straight line. But on top of that, you can do the scientific research and find that projectile motion lends itself to parabolas. Just the physics behind it all indicates that you should be looking for a parabolic motion when you talk about balls that are being thrown through the air. You've got to choose your parent function and your transformations on that parent function really well based on both statistical evidence and scientific research that you report. So tell us why you chose what you did, and the why should be in terms of stats, like r-squared values, and also in scientific research. Next, I'm going to be grading you on Desmos Technique. Most of you have really good Desmos Technique, but it is a little annoying to see people sometimes having Desmos graphs that have errors or warnings or slides or rounding things when they don't need to round. For example, if you're calculating the h value towards the top of this Desmos slide, the best thing to do is, if you already have a and b calculated from a regression, then just type in the formula h equals negative b over 2a. That way you don't have to round. You get a near exact value of h, and it looks good. It's an efficient use. It's purposeful. It's concise. It's beautiful, and you're using functions, formulas, tables, constants, and notes really well. That's what, if you want to get the wow, then that's what you have to do. You have to be using functions, formulas, tables, constants. Oh, and notes. You see kind of above the table, sometimes people want to write a note to the person who's looking at it, and you can if you press a quotation mark, then that starts a note. Or you could also press the plus button at the top left-hand corner. The same way you add a table, you can also add a note. And it's a good way to document what we're looking at. Organization and aesthetic, in order to make this doable within the 2 hours, I mean, very few people that I've seen have spent less than 2 hours on their project that they've submitted. And we've got to all fit this within the 2 hour mark, and I want to make sure that you can do these in 2 hours. And then you also won't have a partner, so that's kind of, that can be scary also. So what I wanted to do was I wanted to make it a lot easier to get and exceed the requirements rating on organization and aesthetic. It doesn't have to be amazingly well, like you don't have to go out and do acting and record yourselves. Like you can't walk around the examination room and say, "Hi, I'm going to throw a ball in a parabola." There's only 3 different categories here. If you just throw everything together into a video, and it doesn't look sloppy, it's well organized, then you're going to get an exceed the requirement 6%. If you can somehow pull off some sort of fun to watch, compelling Hollywood production thing, then that's the 8%. But no one's going to get 4% or 2%. And it's just going to be a lot easier to get this exceed the requirement. The way you turn it in, we can't submit them onto public playlists because it's a final exam. You have to. I will put them all on a playlist, but I won't publish it until after the whole thing's over. So you will be able to see yours and other people's projects, but not until they get graded, and not until the whole thing, not until the proctor says time is up. So what you're going to have to do is you're going to have to email me a link, and it'll flood my inbox, and I don't like that, but that's what we're just going to have to do. Just when you publish the whole thing, instead of contributing to a playlist, email me the link. And then the approved by Bergmann, we're not going to be able to do either because it's a final exam. You'll be sitting in rows and columns, and besides, I can't approve your work when we're doing finals. So that's how submitting the project is going to be a little different. Overall, this rubric is already on Haiku Power School. You can take a look at it, and we're going to be using it as well. Not just for the final exam. I want to practice for this final exam by doing some warm-up projects. Your Chapter 5 project is going to be using this format, using this rubric, and I'm going to give you access to data that you have to put onto Desmos and then make a prediction after choosing a parent function and transforming it. So the next thing you need to do after watching this video is give me some feedback. I want to know what's going on. I want to know how you feel. What are you excited about? What are you worried about? Do you have any ideas to contribute moving forward? And we're going to do a post-it, like if you're in the CEL space, and if someone puts a giant piece of poster paper up on the board and gives everyone post-it notes, and you write your idea on a post-it note and you stick it somewhere on the poster board. Well, we're going to do the same thing, except we're going to do it digitally. So I want you to go to this website, which I've already emailed you, and I want you to put your digital post-it note up on this website, and we'll all be able to see it, although I think it's going to be anonymous. I know it's going to be anonymous, so treat the space with respect, and tell me what you think about what's going on. I want some feedback on this, and then we'll move forward from there. So after you do the digital feedback, then you actually do have the option of starting your project. I put your data on my SCH in the comment for this project. You won't have a grade next to this, but you will have a URL that you can copy and paste into a browser and take a look at the actual data. You don't have to start that now, but if you wanted to do it in advance or take a look and see what's going on, then you can. The first step after watching the video would be to put the data into Desmos somehow. That's always going to be the first step in these kinds of projects. Anyway, I hope you enjoy the video. Hope you are excited about what's going on. But I also want you to let me know if you're worried about what's going on in the form of the feedback that's on the digital post-its. I will see you in class. Take care.